We're going to present Bettina Rickert, Philip de Souza, to moderate a presentation about holistic risk assessment and management.
All right, welcome to the last session. And in this session, we are going to look a bit into different corners. So for the water safety plan, strictly speaking, we're always looking at the water supply, which is good. But there are new approaches looking into different corners and trying to connect the water safety planning with other aspects. We've heard about sanitation, we've heard about climate change, etc. And we are going to look in a few of these corners in this session, all the way from the catchment to the distribution system. And I would like to welcome our first speaker to the stage, Ana Lía Garrido. She's a human biologist and master in integrated coastal management from the University de la República. And she's currently doing a PhD in Wageningen in the Netherlands about the impacts of cyanobacterial blooms in the Rio de la Plata. She's an associated researcher in the South American Institute for Resilience and Sustainability Studies, and we are going to hear from her today about the risk assessment of the inner Rio de la Plata as a source of drinking water regarding cyanobacterial blooms. Anna, the floor is yours, and the microphone too.
Hello. Thank you very much. Well, as Bettina said, I'm doing my PhD in Wageningen, and I'm working also with Bernardo Zabaleta from Facultad de Ciencias, Universidad de la República in this topic. So I will start talking about the context of this presentation. There is a proposed drinking water treatment plant that is proposed to be installed in Arasati, which is a beach in the Rio de la Plata, a place in the Rio de la Plata, in the middle Rio de la Plata. And this project aims to provide a second drinking water source for Montevideo and the metropolitan area. Well, the location of the plant nowadays is like this. It's a beach with very not very known for us, but there is the place. So, talking about water safety plans, I found this manual from Chorus and McHugh from 2021, which says that the water safety plan should comprehensively assess all potential hazards and threats throughout the water supply system, including the events that may cause them. So, in their approach, they propose that the most fundamental control level is the catchment management to prevent or reduce nutrient loads to the water body. This is about specifically cyanobacterial blooms. So, in this case, if the measures can be taken in the catchment scale, they say that the management option is to control human exposure. So, as we are going to see, we are talking about a very huge basin, the La Plata Basin, which includes 5 different countries and is the second largest basin in the South American continent. So this basin is subject to various anthropogenic pressures, including agriculture, industrial, and urban effluents, and river damming. And the estuary itself has very complex dynamics, and these dynamics also condition the physicochemical and biological conditions, which are highly variable. So to understand a bit these complex dynamics, the first thing that we have to understand is that the limit, or the estuary is very, the limit of the estuary is very variable, because it's where the fresh waters from the big rivers encounter the oceanic currents. So these dynamics are, we have here the turbidity front, or the frontal region of the Rio de la Plata, and we see that the location of this turbidity front can be very variable. And here there is a work from Maciel and collaborators who studied the turbidity front from satellite images, and we can see that flows of the rivers and winds, direction and speed, are condition the location of the turbidity front. In the red point, we can see the water drinker plant. So here we see that in some conditions, the turbidity front can get to the, let me see if I can do this, yes, can get to the point of Arasati. So this is when southwest winds dominate in the outer Rio de la Plata and oceanic zone. We can have the turbidity front closer to Arasati, and here with low flows of the Uruguay and Paraná rivers, also we can have the turbidity turbidity front near Arasati. So we talking about cyanobacterial blooms in the Rio de la Plata. There are a few works that have looked at that. This is one of Zabaleta and collaborators from Facultad de Ciencias, and they studied the frequency of cyanobacterial blooms in the Rio de la Plata from satellite imagery from 2017 to 2021, and they calculated the NDECA index as a proxy for cyanobacteria levels. So their findings are that, the main findings are that there is a high variability in the occurrence of cyanobacterial blooms, and here they also related the occurrence of the phases of the El Niño phenomenon with the occurrence of cyanobacterial blooms. And here you see that during El Niño phases, they found that the frequency is not high, but during the La Niña phases, you see that there is a high frequency of blooms, and also they identified 4 different zones of the Rio de la Plata that have more frequent events. So, and here you see that Arasati is there. So, but they didn't calculate levels, only they did determine a threshold and said, well, if the image is over this threshold, we consider that it's a bloom, and if it is above this threshold, it's not a bloom. So, and here we see another work from Krug and collaborators, also from Uruguay, from the eastern regional of the university, that they studied the evolution of these cyanobacterial blooms, specifically in the lower Uruguay River. So, because there was a debate about the the main drivers of these blooms, or the abundance of cyanobacteria, and they did this work to study the possible different drivers, and they found that, well, first of all, there was a sharp increase of cyanobacterial abundance in the Rio Uruguay, at least, but we know that also in the Rio de la Plata is happening the same. And this is starting in the 2000, and then they tried different models, and they found that the most significant model, or the only significant, was this, that says that the cyanobacterial abundance is significantly related to the crop and pastures land use cover, and not significantly related to the temperature, the precipitation, and the flows. This is to study the trajectory, not to say that these variables don't have an effect on the blooms, but the changes during the years are explained by this model. So it's a path model. So this was a very important work, because until this moment there was still a debate about what is the main, could be the main drivers or causes of increasing cyanobacterial blooms. And this demonstrates that this exponential increase is also congruent with increase in phosphorus concentration, also in relation with increase of intensive agricultural activities. So, taking into account this and going back to the problem that to understand the possible risk of cyanobacterial blooms in this part of the Rio de la Plata, we know that the monitoring system of the inner and middle Rio de la Plata in the Uruguayan coasts doesn't routinely analyze parameters to measure cyanobacterial biomass, identify phytoplankton species, or quantify cyanotoxins. So this study, or what we are trying to do, is to integrate different methods and sources of information to estimate the frequency and intensity of cyanobacterial blooms using multiple proxies. So from my work, I was studying the impacts of cyanobacterial blooms to recreational activities, because when I started my PhD, the drinking water wasn't it wasn't proposed. So I was already studying the Rio de la Plata and looking at data. And one of the sources that we have is the National Network of Beach Monitoring, which uses visual inspection to classify the water status. And this is, there are some beaches that are included in this network. And for example, Arasati is not included, but Boca del Cufré and Quixú, which are close to Arasati, well, the closest in this network, are included. The frequency of sampling is 4 times per month, as most. And then the other source of information is the health flag register or records. The health flag is used by the lifeguards during the summer season as a warning sign. So if there is a level of cyanobacterial blooms that is high enough to warn the beachgoers, they place the health flag. So according to the protocol, they can put the health flag, or they should place the health flag only when the bloom is intense and it forms a green paint-like stain with foam. So they monitor the beach every day, but only in summer season. And this hasn't been used for a long time, so we have records from 2022. This is data from the National Environmental Observatory of the Ministry of Environment, and also the Facebook page of the lifeguards, because it's complementary. So we see that Arasati, in the summer 2023, had 7 days with high intense blooms. And then the other beaches also had more or less the same amount. So this is one proxy because we know that those days the blooms were very intense. So the probability of having toxins were high, and we don't know what happened the rest of the days. For example, if there were dispersed bloom, we don't know. Okay, so in my work, I went to sample, I went to observe this region in March 2023 during a high intense bloom, and I took some samples from Guizhou and Fomento in Colonia. Arasati is more or less here. And I took the samples to the Latu to make measurements of microcystin levels. The highest bloom gave me these results: 75% micrograms per liter of extracellular levels and 518 micrograms per liter from intracellular concentration. And that was the highest value, but also in the dispersed bloom we had 13.2 micrograms per liter in the intracellular concentration. So I register, I communicate this to the person who is in charge of recording this in an international database, and I found that there weren't many data about these cyanotoxins, while that doesn't means that the blooms weren't there, but they are not being monitored. So now we agreed with Bernardo Zabaleta, which is my colleague, to study this specific case or zone about trying to estimate chlorophyll levels, and we are using the same more or less the same approach that they use in the work from high frequency estimation, and we are trying to translate the NDCA levels to chlorophyll A concentrations. And we are using a formula algorithm proposed by Maciel and collaborators in 2023 to calculate this. And the preliminary results are in this zone of the Rio de la Plata and these specific pixels, we get these levels. So the lowest line, that's maybe you don't see very much, is 12 micrograms per liter of chlorophyll A. The second line is 24 micrograms per liter of chlorophyll A, which is the limit for recreational activities. And you can see that you have many values for over those levels. Now I have only this table to show that this percentage and the relation with the El Niño, La Niña events, but this is we are going to publish this article soon, but to submit this article, and the conclusions are that the high chlorophyll I levels estimated from the zone of Arasati and the scarcity of data about cyanotoxins should be taken into account for the assessment of the Rio de la Plata water as a source for drinking water. The information presented here raises concerns about the suitability of the water of Arasati coast as a source of drinking water, and monitor efforts should increase and should introduce variables that are not being routinely measured, such as cyanotoxins. Thank you very much.
Thank you very much for this great presentation, looking into the catchment with a particular focus on cyanotoxins. And are there any questions in the audience? Over there, please.
Bien, interesante presentación. Simplemente algunas reflexiones y alguna consulta. De alguna manera el estudio de correlación está basado en ese índice en fotos satelitales. Querría preguntar si han tenido algún estudio de estratificación, esto es, para eventualmente correlacionar niveles de inferencia de presencia de Bloom-Sal gas a nivel superficial, que son los que de alguna manera mejor correlacionan con la foto satelital, con lo que pueden ser concentraciones a otras profundidades. Simplemente para tener un contexto, no necesariamente para lo que es exposición a baños, sino en el caso de la mención a Arasatí, que viene directamente correlacionada a fuente de agua bruta para abastecimiento, donde eventualmente la captación es a nivel más profundo, ¿da? Después, los niveles el modelo es interesante, los niveles de clorofila A correlacionan bastante. De hecho, en la zona donde está proyectado la captación, hay una sonda multiparámetro que registra fluorescencia clorofila A con valores de media y estadísticas, particularmente incluyen el año 2023, están en los órdenes. Digo, simplemente como reflexión, inclusive aplicando criterios de tratabilidad de aguas y fuente, de alguna manera los niveles no son en lo que hace hasta 50 de clorofila pasible de ser tratados con métodos convencionales, y este proyecto de Arasatí particularmente, justamente por la eventual presencia de Bloom, tiene herramientas, las más modernas, lo que son interozonización, biofiltración, como para atender picos y claramente que exceden los límites que fueron mencionados aquí. Entonces, simplemente la reflexión, y tal vez eso es como una reflexión general, como reflexión particular, me gustaría saber si han habido estudios de estratificación para la correlación con el índice, para tener una medida más integral de lo que es la calidad a distintas profundidades. ¿De acuerdo?
Sí, gracias. Como ya dije, los datos de esta zona son muy escasos. Entonces, sabiendo que OCE tenía un convenio con el INFIA, hicimos una solicitud de acceso a la información para obtener esos datos de la sonda que está instalada en esa zona. Lo obtuvimos hace poco tiempo, o sea que lo estamos analizando. También obtuvimos un informe que hizo el INFIA. Por lo que vemos, esa sonda tiene sí datos de fluorometría de clorofila A, ficocianinas y materia orgánica. Y también ellos hacen muestreos del agua de ese lugar para estudiar en laboratorio el nivel de clorofila. Por ahora, las calibraciones que ellos han hecho son muy básicas porque no tienen suficientes datos, pero lo que sí se ve es que los valores de clorofila medidos en laboratorio son mucho más altos que los valores del fluorómetro que está en ese lugar, porque la relación siempre es el medido en laboratorio va a dar más que el medido con el fluorómetro. Eso es lo que pude ver en el informe. Por otro lado, sabemos que las imágenes satelitales solo nos dan una información de el nivel superficial, o sea que por ahora lo que tenemos es lo que podemos obtener de esas fuentes de información. Por otro lado, por lo que yo estuve leyendo en el estudio de impacto ambiental, los valores de partida de los que empiezan a hacer los análisis de proyección, hay un solo valor que toman de cianotoxinas de Colonia, porque en ese lugar, en esa sonda, no están analizando cianotoxinas, solamente nivel de clorofila. Entonces, tampoco analizan las especies que están presentes. Entonces, ese valor de cianotoxinas que presentan para hacer las proyecciones o calcular la máxima concentración que se ha encontrado en esa zona del Río de la Plata, creo que habla de 10 microgramos por litro. Por eso me parecía interesante traer estos datos de este muestreo que yo hice, muy puntual y muy, muy humilde, para decir, bueno, en realidad la poca información que hay nos dice que los valores podrían ser mucho más altos. Entonces, eso es lo que yo te puedo decir con la información que tengo.
Thanks a lot for the clarification. I think we have time for one more question over there, please.
Bueno, muy buen trabajo, Analía, la verdad que no lo había visto y está muy interesante. Una consulta que quizás va un poco asociada a lo que él planteaba es, entiendo que los datos que se tienen disponibles son solamente los de clorofila, o sea, las medidas que tienen, pero ¿Han encontrado algún tipo de información acerca de las especies de esos que aparecen, o sea, asociadas a esos bloom? ¿Es parte de la información que había que empezar a relevar para poder terminar esa correlación entre la presencia de clorofila A y la presencia de especies potencialmente productoras de cianotoxinas?
Sí, perdón que no lo dije. En realidad, en este caso específico no tenemos ningún análisis de qué tipo de especies hay, pero suponemos, porque es lo que viene pasando en la mayor parte del Río de la Plata, que son el del complejo Microcystis aeruginosa. Entonces, seguramente sean esos, pero nada dice que no puedan aparecer otras especies.
Thanks a lot, Anna. I think that was a great presentation looking into the catchment and looking into some special challenges that may come from the catchment and how that can be related to the drinking water supply. So thanks a lot.
Thank you.
Now like to announce the next presentation and the next speaker. The next presentation will look at a completely different aspect, and that's the business intelligence as a tool to improve the holistic risk management in the water safety plans. Our speaker is Diego Pinto. He is a biologist at SANASA, the Society for Water Supply and Sanitation of Campinas, SP in Brazil. With 12 years of experience in drinking water quality, microbiology, and parasitology analysis, he oversees the processes of risk assessment and management in SANASA's water safety plan. He worked as a consultant for the Pan American Health Organization, serving through the Ministry of Health of Brazil. And he holds a master's degree in parasitology and environmental health from the State University of Campinas. So, please, Diego, the floor is yours. Thanks.
Thank you. So, good morning to all. First of all, it's a great pleasure to be here with you and to share our work in such important conference like that. And my name is Diego, how she said. I'm from Brazil, and I'm not a native English speaker, so I will do my best to make myself understood. And if you have any questions, please don't hesitate to ask, okay? I will present the work entitled Business Intelligence as a Tool to Improve Holistic Risk Management in the Water Safety Plan. Okay. It's just a summary with the introduction. Water Safety Plan in Brazil regarding to Brazilian legislation. Water Safety Plan at SANASA Campinas. And the BI tools that we are developing. And so some conclusions. Firstly, I would like to show you the company where I work. This is SANASA, the Society for Water Supply and Sanitation of Campinas City. This company is responsible for the water supply and also responsible for the wastewater collection and treatment of Campinas. Okay. Here we can better visualize the location that we are talking about. Brazil is here, the state of São Paulo is here, and highlighted in green on this map, we can see the Campinas city or the metropolitan region of Campinas. It's important to say that this region is a very populous, urbanized, and industrialized, and all these features impact directly on the hazards and the risks that accomplish our water supply system, okay? Here is some numbers, an overview with some numbers and of the Campinas, of the city and the company. We are talking about a city with more than 1 million inhabitants, and almost 100% is supplied by the water, the potable water of SANASA Campinas. For that, more than 2,008 million liters of treated water are produced daily. So regarding to the water safety plan in Brazil, I would like to highlight two of the main legislation that we have there. The first one is the Brazilian Drinking Water Regulation, called Ordinance 888 of 2021 by Ministry of Health. Okay, this regulation is responsible to set the rules, to set the drinking water rules, the drinking water standards. And the second one is it's a guideline for preparation and implementation of water safety plan. It's called ABNT NBR 7008 of 2023, of technical standards. Now, talking about the water safety plan at Sanasa Campinas, which begins in 2012 with initial studies, okay? Our water safety plan adopts the model recommended by the World Health Organization and International Water Association. It complies the Ministry of Health due to the Ordinance 888 of 2021 and follows the ABNT NBR 7080 that I talked in the previous slide. So the water safety plan, its origin in this framework is managed by the company, the companies that are responsible to manage the water safety plan in Brazil. And one of the aim of the water safety plan of Sanasa that I am talking in this work is the integration of all of our stakeholders, the importance of integration of our stakeholders, the internal stakeholders and external stakeholders, okay? Here is just some overview of how the water safety plan of Sanasa, how we run the water safety plan of Sanasa. How we have just 15 minutes is just in summary, 7 mainly steps. With step 1, the monitoring plans for each stage of the system. Step 2, we have with the monitoring plans, we could identify the main hazards and hazardous events. And so step 3, we do the risk classification and priorization with tools like risk matrice. Step 4, the critical control point definition using tools like the decision tree, okay? The control measures, the establishment of control measures, the emergency plans for each hazard or hazardous event, and the routine management. All of these actions are in accordance with the good practice, multiple barriers, and hazard analysis and critical control points. And this framework, this group of steps are organized and recorded in control plans. So each step of the water supply system is managed by a coordinating board, and they organize all of these actions in control plans that are recorded in the ISO 9001 that Sanasa is certified since 2004. Okay, so how I said, I will focus on the step 7, routine management, okay? So in the routine management, we have this framework, like I said, monitoring plans, hazard identification, risk classification, critical control points establishment, the control measures, emergency plans. And we are working in a way to integrate and synchronize the management practice with incorporating some technology tools like drones, monitoring station, softwares, supervisory system like SCADA system, database synchronization, and business intelligence tools. That's a way to analyze all the information. So aggregating these technology tools to pursue our better water safety management, okay? So, talking about the water safety plan, the BI tools that we are working on developing workflows to automate and to structure, like I said, all the data that are involved, related to water supply system, all the steps of the water supply system, okay? So these records, this data, these indicators are available in a digital platform divided in 2 modules. The first one is called Water Safety Plan Digital. Okay, it's like a communication tool, a communication with the customers, the clients, the people in general, the universities, anyone. It's like a report with indicators and records, and is available at this website of SANASA. And the second tool is it's called Water Safety Plan Management. This one is an internal management tool that synchronizes all the stakeholders' data. The purpose of this tool is to support the decision making, okay? To facilitate, to analyze all the information of the water supply system and to support the decision making of the managers. So let's start with the Water Safety Plan Digital. After joining all of the system, using the technologies, we got a set of dashboards that includes an introduction, hydrological monitoring, raw water quality, treated water quality, risk management, and a tutorial on how to browse this system, okay? The dashboard with introduction focus on conceptual aspects like an overview, objectives, and in this kind of more introduction conceptual aspects. And there is also in the introduction dashboards the description of the system, like we must have in the manual of water safety plan. It's a PDF document that anyone can access with more details of the entire water safety plan, from catchment through the water treatment plant to the network, the distribution system. So the next dashboard, called hydrological monitoring, we can analyze in real time the data about our system, our raw reservoir system. In that region, we are supplied with a group of six reservoirs called Cantareira system, which are responsible for supply more than 8 million people. So we can analyze data as the total volume per day or per period, as you can select on the filter in this dashboard. And we also can analyze data with about the Atibaia River, that is the main river of Campinas City. Okay, Campinas is supplied by a superficial water, this river, Atibaia River, that is responsible for more than 1.2 million inhabitants. So we can visualize the information as the level in the catchment point, the precipitation, temperature, and you can see in that day or on a period as you can select in the filter. The next dashboard is about raw water quality. And we can analyze the data of raw water, including an index, water quality index. I must go faster because I have just 5 minutes. Okay. And we can analyze this index about raw water quality and the next measurement, average, minimum, maximum, okay, and other information in the graph. And the next dashboard is about the treated water. The first one shows general information regarding to the responsibility of the company. The second one is about the laboratory analysis. And the last is about a summary with the samples in that period, the parameters analyzed, and the classification in potable or non-potable water. In the risk management dashboards, we can, after choose a hazard or hazardous event, you can see the score of risk. In that example, high 20. I cannot read here, but you can choose a hazard and see the risk score. The decision tree, where is a critical control point, and in this dashboard, you can choose a step of the water treatment plant, and on the next, you can see a description and choose the critical control points for the next dashboard. You can analyze all the information about this hazard, like the hazard, type of risk, probability of occurrence, severity of consequence, risk score, decision tree, the emergency plans, the approval criteria, and other informations, okay? So now the second tool, Water Safety Plan Management. That was the tool for internal use, okay, for the company use. We have a set of 3 dashboards. The first one is to it's a specialization of the sampling points. So you can see through 3 maps. The first one shows the system, the water system. It shows where this water comes from, because we have 5 water treatment plants at Sanasa in Campinas. The second map shows the sector and subsector that we have in our distribution network. And the third map shows the exactly sampling point address, okay? So we have more than 2,000, almost 2,015 sampling points divided in 19 routines and 9 categories. In this table, we can see information about the points, the routine, the water system, the sector, the address, okay? The type of material in that point, in the distribution network, all of the data. The proposal is to integrate all of the data in one system, okay, in the category. So here you can choose in the filter. I want to see the routine A. So routine, there are 16 monitoring points, and I will analyze the data, the laboratory results, specifically in what I chose. The next dashboard is the analytical monitoring. With this dashboard, we can analyze all the results. So we can see the number of analyses realized in this period that you selected, and how many were in accordance or not, in compliance or not with the legislation. Okay, so you can investigate some eventual non-conformity in your distribution system, or even prevent some non-conformity in your distribution system. Here we can see the filter to choose in accordance or not the legislation, and all this information we can analyze with regarding the month, the system, the sector, category, routine, the points, the material of type of network distribution. And the third and last dashboard of this tool, it's called the Water Quality Report. It's like a summary, a report that we can analyze all the informations in a summary way, okay? Dividing to our water treatment plants and some parameters. And we have a final classification, if it supports, if it's accordance or not the legislation. So, in conclusions, what we are developing is the business intelligence tools and also other technologies, not just business intelligence tools. We have in Sanasa a situation room that is able to integrate all the operation of the company. And the purpose of our job is to put the quality and the safety of water inside this technology system, to use this technology system in pro of the quality and safety water, okay? So this in purpose in order to integrate the workflows stakeholders, to improve, to get better decision making. And the final, the water stakeholders, here is some of the stakeholders of Sanasa, of the water safety plan of Sanasa. And the big goal, the great goal, is to articulation the workflows, but most importantly, they articulate the control measures of each stakeholder of water safety plan in order to get a holistic risk assessment and management. So here is some reference, and that's all. Thank you very much. Gracias.
Thank you very much, Diego. It was very interesting for me personally, because with the new legal requirements for risk management, we had a lot of discussions in Germany whether to use such tools, whether you could have a unified tool, etc. And it was also great to see that you're separating between internal and external communication. So are there any questions to Diego? It's up there.
Hello, Diego. I'm Fernando from Universidade Federal de Santa Catarina, Brazil. Thank you for this great presentation. I would like to ask you, how did you manage to engage staff on this with this tool, this new tool? And did you already see, or could you highlight the most important impact after that implementation?
Okay, thank you for the question. Yes, this is the big challenge, to engage the people, because, for example, Sanasa is a company with 50 years of existence, okay? So in this long period, each sector, how I said, each step of the water supply system is a coordinating board. So it has their own management practice. And this management practice has the evolution of, a specific evolution of this sector. And since the beginning, it's okay to work on, but we need to aggregate and to show the importance of this, to integrate all of the stakeholders. It's a big challenge. So in many cases, depends on personally the person who is making the decisions, or one thing that's very, very important is the accordance with the high manager. Okay, the director is supporting this kind of project, because if this project begins just on the operational staff, it's more difficult. So the agreement of the high staff, the high manager, is very important. And the second question, sorry.
Could you highlight, or do you see already some impact of the application of this new tool?
Before to develop this kind of systems, it was very, it was more difficult to investigate some problems, to investigate some non-conformities, or to prevent, because with kind of the integrate data, we could integrate even the type of the material of networks distribution and eventual parameter that's non-conformity. We could analyze and confirm why this non-conformity is occurring, is happening, okay? So we can, it's much more, we can analyze in fewer time. And the purpose is to aggregate other systems of the company. It's just the beginning of the project. Thank you.
Okay, so thanks again, Diego, for this great presentation. It was a good look into how to manage the water safety plan rather than just managing the water supply. So thanks a lot.
Thank you very much.
Now Bettina's forced me to speak, so I will speak. Our last speaker of this session, and I think it's the last talk of the day, before we move on into tea and then the closing ceremony, is Associate Professor Thomas Patterson from Chalmers University. He was one of our keynote speakers, so I'm sure you're all familiar with Thomas. He's also been a chair of a couple of sessions, so he's had a busy conference too. Thomas, it's the final talk. I know it's always difficult when it's the final talk, but at least it's still the morning, so people are still awake. All the best.
Thank you. Thank you very much. Thank you for being here. I will present a work that has an WSP approach, but it's not a full water safety plan work. But it's, as I said yesterday, we are working a lot with tools and methodologies. So I will present one of them that I briefly mentioned yesterday. And that is strategies for effective leakage risk management in a distribution network. So, and it was interesting to hear first about the raw water source problem described for the basin Rio de la Plata. and then the full water safety planning for the whole system in Brazil. So I will finish in the end of the system, which is the distribution network. And leakages in the distribution network is, of course, a significant water loss, but it can also pose a health risk if you have the unfortunate situation that you have an intrusion of soil water that is surrounding the pipes. So in Sweden, we have around 5,000 repairs in the distribution network per year, which is quite a lot, and around 17% of the total production leaking out in the pipe trench. So the aim of the study here is to present and propose a strategy for how to most efficiently work with the control and put in measure to reduce the risk, including the health risk due to leakage. So the water safety plan framework that we show here is based on a case study in Sweden. So, I don't have so much time, so I cannot go through everything here, but we follow the water safety plan framework. So we have the module 2, 3, and 4. So first step is to have the data collection. What is the data for the system? And I will come back to that. It's a small system in south of Sweden. A next step is to make the risk assessment. So identify what hazards do we have, and also the risks that we can try to quantify. So we have the probability and the consequences that we then try to quantify into pretty much a risk matrix. So we will use the probability of pipe burst, logistic regression is used. Hydraulic consequences due to leakage, so pipe criticality. And then we make a health risk assessment for the consumers in the end of the distribution system using QMRA, quantitative microbial risk assessment. Third step, identify control measures, which is done at the desk together with the experts of the water utility, researchers and other experts, and then discuss this. And the last thing is to rank the strategies. How efficient are these different strategies? And you can put in a lot of different criteria. So we use a multi-criteria decision analysis methodology. So I will go through it quickly. So this is the setup. So first, the case study, a small system. You see the data here. It's around 280 customers, and that's equal to 914, in this case, person equivalents. So there are some but activities there that is not only households. And this is, of course, this small one is a part of a much larger that we also use for training. I come back to that. So the risk assessment, the probabilities, we make a logistic regression, kind of machine learning, that my PhD student have worked with. He's good at that. And the model was trained not on this, but on the larger system to find out the risk for pipe bursts. So by training the system, we applied it on this one. And as you can see here, we predicted, from the model, we predicted by real data. And the real data was 26 failures, bursts, and the model could find out right now. It's an ongoing project, so we still improving 17 of these, so 65% accuracy. And also the model predicted 423 out of 429 that had no problem. So that was one part, the input. And next is the consequences. So by hydraulic modeling, we identified which of the pipes that have a burst will cause highest effect for the whole system, which have most nodes affected. It's a lot of data and information here, I know, but I just briefly mentioned this. I cannot go into details. It will be published, of course, this work when everything is done, so hopefully you can look out for that later. But the hydraulic model is used here, and then we identified which are the most critical pipes, high, medium, and low, and the high ones are, of course, the ones we are most interested in. But this is one part of the input data. Then we come to the health risks, and that is assessed first due to real measurements in the pipe network when they dig up for repairing a pipe or exchanging a pipe. We have been there measuring the, sorry, that was wrong, this one. We have been here and taking samples and measure the microbial contents, E. coli mainly, but we translate it to pathogens. But also chemicals have been analyzed. So that's also part of the big work, but I won't go through the chemicals here. So by this, we calculate the risk. And the risk is, of course, the probability times the consequence. And we have one probability of failure, as I showed earlier, first, and then we have the consequences, both the critical pipes, which affects most people, and also the health risk. So by putting this together, we got, for the different pipes, we got either low, medium, or high risk, as you can see here, where you have the red pipes. So next step was to identify the control measures, and that was the desk study, so to speak. We sat together with water utility staff, other experts, researchers, us also, and used this multi-criteria analysis methodology to find out which of these measures to avoid this to happen is the best. And we used TOPSIS technology, as you can see up there, to identify suitable strategies and which one are the most effective to apply. I come to which we had. And the stakeholders were given questionnaires to both prioritize the alternatives and to assign weights for the evaluation criteria. And I think I don't have time to do that in detail, so you can have a quick look here. So how we weighted was cost, executability, effectiveness, risk reduction, social concern, and reliability. Yep, and here are the... I'm not friend with this technology. Here. So here are the different measures that we try and test. So here is the result. So first, the best result here, from the result, the best measure is to use, as you see, number 1 here, a pipe replacement. That's the most efficient one from this. Next is active leakage control. And the third one is pressure management. And the fourth in the list here is the pipe repair and rehabilitation. So we see that the top-ranked strategies, they more suggest prioritization on investment in physical infrastructure. So replacing the pipes with new ones. Thank you. And the results suggest also that we should address immediate physical issues, which seem here to have the most significant impact on the health risk reduction. So here it also highlight the importance of proactive approaches. So to conclude, The study presents a more structured way to an effective management of the leakage and what strategies should be emphasized at the associated risks. And the study is also structured around the water safety plan. So we deliberately tried to follow the water safety planning manual to make it more easier to adapt this later on. And of course, there are a lot of details I haven't talked about here that you need to know if you should do the same thing. But as I said, it will be published hopefully end of this year, and then everyone can read. So, and there are also some limitations and further work, but I don't go into these details since we are running out of time. So that's it. So thank you for listening. If you have any questions, I'm very happy to answer.
Thank you, Thomas. Very interesting work, I think, and nice to see also how, you know, leakage and the influence, how you bring in the water safety planning into that. Very interesting. Do we have any questions for Thomas on his presentation in the front?
Yeah, thank you very much for the nice presentation, and it's very good work. So I would like to, you have said that you use that ML, machine learning, for your pipe burst probability. Can you just give some idea how you have done that one, or what is the input data you have taken basically to find out the probability?
It's a very good question. Unfortunately, I'm not the right person to talk about details. I'm very sorry for that. But it's, as I showed, okay, but just go back quickly. Too far, I think. Here. No, sorry, wrong direction. Here, that was what you meant. No, I cannot go into details. It's we have another professor that is expert on AI and machine learning, and he, together with our PhD student, they went through this actually when I was at the conference in Toronto. So they have worked when I've been here and there. So, but here are the input data, as you can see. So it's pipe characteristics, operational characteristics, environmental attributes, and failure history. So putting that together in a machine learning approach, they trained the system on real pipe bursts in the larger area that is not this one, but the other one connected upstream. So by training that model, machine learning model, on that, we applied it on this later on. It was not an answer on your question, but I tried to a little bit elaborate. Yes?
So it's a real data, basically,
yes,
collected from the network?
Yeah, it's real data. It's data supplied from the water utility to us, so we could use it. So they gave us all that type of data. So it's real data. It's some work to get it, of course, but...
Yeah, it's very difficult to get data.
Yeah, often the water utility, they have the data, but to put it together can be a little bit time-consuming. But when you have it, I'm happy to share this when we have it published. So if you're interested, just contact me. You have the... Fortunately, I don't think I have my email address here, but just come to me and I give you my address. I'm happy to send to anyone that are interested. Thank you for the question.
Thank you very much. Yeah.
Great. Any other questions for Thomas over there?
Sí, perdón, pero en español.
Just a second.
Yes. Disculpe, entiendo que con el uso de este programa se indica a la compañía proveedora qué tubería recomiendan sustituir. Usted indicó al principio que el porcentaje de pérdidas que tienen es del 17%. Para nosotros eso es bastante bajo. Usualmente, ¿cómo es que actúa la compañía? ¿Cada cuánto sustituyen la totalidad de sectores? Y con esto pasaría a decir cuál es la tubería que hay que sustituir. ¿Es así?
Thank you. It's a good question. The leakage, if we start there, it's 17% in average in Sweden. There are water distribution systems that have 50%. There are some that have 4%. So it's a variation, of course. So there are also bad ones. But in general, it's quite okay. But if we compare us to our neighbor Denmark, they are down under 10, 5 to 10. So they are really good. So that's it. What was the question about the pipes? Which pipe they should replace? What we give here is, of course, not the full truth in any way. It's a suggestion. So it's kind of decision support for the water utilities. So it should not be seen as the truth. This is a way of trying, with the data available, the methodologies that we have, try to put together this into a final result of a prioritization list. So it's a suggestion, and in the end, it's the water utilities, of course, that need to consider: is it possible to exchange this pipe, and so on. And there were also a question on how often or how much we rehabilitate the pipes, exchange the pipes. In the second largest city, Gothenburg, where my university, Chalmers University, is located, they have improved. So now they have 0.5% replacement, meaning that every new pipe will take 200 years till you exchange it. It was earlier 0.4, 250 years in statistic approach on that. So it's not a high pace on that, but it needs to be improved. The Swedish Water Association worked on a report where they talked about around 400 billion Swedish crown, which is 40 billion US dollar. The coming 15 years needs to be extra funding to exchange the pipes. So we have a big problem in Sweden to exchange the pipes. So right now it's a relatively low leakage rate, but it will be worse if we don't do more. So I think this also can help them to start to understand which are the ones we should hopefully start with. Yeah, thank you for the question.
Great, thank you. And perhaps just a comment to follow up on that question is your low leakage rate of 17% as an average is probably like best in South Africa for a municipality.
Okay.
So, and again, 5,000 bursts in the year is probably what City of Cape Town was having prior to the 2017 drought, about those number of bursts in the year just for one city. So I think there's, the conclusion here is that if this could be applied elsewhere, there could be huge benefits to some of the other countries that face perhaps more significant challenges. Yeah.
Yeah, and we are very happy to collaborate with any water utility that would like to provide data, and we can probably find out a way to carry out such a project. We have a lot of students that are very interested to come out in the world and see other things than the Swedish systems. So just contact me and I will be happy to discuss that with you. Thank you.
Excellent. Thanks, Thomas. Can we give him another round?
Thank you.
And I will ask my co-chair to close the session.
Thank you very much. And I think we've seen nicely aspects that you can integrate into water safety planning. It's not just a closed system where you look at the water supply only and you don't look left and right, but it is very helpful to see what's happening in the catchment and to collect as many data as you can, even if the database is rather limited, to use tools, electronic tools, to help and make our lives easier, and to also actively communicate with the consumers, because they're the ones who also have to accept whatever is done in the water supply. And to make sure that the water is not recontaminated at the last meters, whatever we've done before, because we want what we've done before to work all the way to the consumer's taps, because that's the overarching goal, after all, of water safety planning, to provide healthy and wholesome water to our consumers. And I think that nicely closes the thematic sessions of this conference, and I hand over to you to announce the further activities.
Well, thank you very much for your presence. Thank you very much for those presenters.